दिया, फिर आंखें मूंद कर ध्यान किया, ब्रह्मांड को मैंने नाप दिया। दिमाग में ज्ञान संसार का ना, पर बुद्धि को एकांत करा। मैं पढ़ता गया, मैं पढ़ता गया, मैंने बुद्धि में ब्रह्मांड भरा। मैं शून्य बना, मैं शांत बना, डी वॉइस मैं देवांश बना। मैं लिखता गया, मैं लिखता गया, अब कोई लगाम विचार पे ना। विचार कोई नकारात्मक सा अब पड़ता ना मन पर भारी। अब बात करे सन्नाटे मुझसे मेरी ही बनकर वाणी। मैं पृथ्वी हूँ, मैं अंबर हूँ, मैं पंच तत्व का हूँ ज्ञानी। मैं अग्नि हूँ, मैं वायु हूँ, मैं सब जानू अंतर्यामी। एक खुली हुई मैं किताब सा हूँ, मनगढ़ंत कहानी बनाता नहीं। मैं प्रलय हूँ, मैं अभिशाप सा हूँ, गर बरस पड़ूं तो ठिकाना नहीं। मैं नदियों के सैलाब सा हूँ, उफान करूँ तो किनारा नहीं। मैं पढ़ तो लेता दिमाग भी हूँ, कभी आंखों से आंखें मिलाना नहीं। दिमाग में ज्ञान संसार का ना, पर बुद्धि को एकांत करा। मैं पढ़ता गया, मैं पढ़ता गया, मैंने बुद्धि में ब्रह्मांड भरा। मैं शून्य बना, मैं शांत बना, डी वॉइस मैं देवांश बना। मैं लिखता गया, मैं लिखता गया, अब कोई लगाम विचार पे ना। हर हर महादेव, मैं हूँ बैरागी भोले, तेरी वजह से हूँ मैं प्रेमी हूँ, मैं पापी हूँ, मैं माल पी के मजे में हूँ, मैं नशे में हूँ इतना ज्यादा कि बुरे कर्म भी ठीक लगे। धन दौलत मैंने जो भी कमाया वो सब मुझको भीख लगे। कभी निर्दयी तो कभी दयावान, कभी हूँ डरा तो कभी भयावह। मैं मदिरा
हेलो,
पानी हूँ, खुद से खुद में बर्बादी
इट्स
हूँ।
वर्किंग बट मेरा हेडफोन का माइक क्यों?
कभी कभी मन शांत ये रहता, कभी कभी बेकाबू है। श्रद्धा और सद्भाव रहे तो हो जाता हूँ पावन मैं, पर भोग विलास और मदिरा पान से बन जाता हूँ रावण मैं। मांस पके जब अब करेगा हम राक्षस बनकर खाएं उसे, पर बेकसूर किसी पशु की हत्या कभी कभी ना भाए मुझे। एक शरीर है दो मनुष्य लगता मेरे भीतर रहते हैं, विनाश काले विपरीत बुद्धि सब कुंडली देख के कहते हैं। एक तो है सीधा बड़ा और दूसरा बहुत ही पापी है, मेरी हरकतों से बस पता चले कब
I didn't know that it'd be so hard, yeah, for me to relax, finding my purpose. I don't know what makes me happy, don't know what makes me sad. I sit around and ponder emotions in my head. I give up, no matter what I do, not enough. I try so hard to stop, I give in to every single bad temptation. And I just wanna feel like a good person, a good person. When I wake every single morning now, I give up. No matter what I do, I give up, I give up. And I just wanna feel like a good person, a good person. When I wake every single morning now, I give up, I give up. I just wanna feel free without any expectations. So many people think they know me, but they only know my music. And there's so much opportunity, so hard to make the most of it. When you feel so depressed and your bed whispers just to stay in it. I think I've had enough of it, I know that I'm not gonna win. Surrendering my everything, I'm giving up, I'm giving in. Nobody understands what I'm going through. Can't explain when you don't come from it. I give up, no matter what I do, not enough. I try so hard to stop, I give in to every single bad temptation.
हेलो
Hold me close till I get up. Time is barely on our side. I don't wanna waste what's left. The storms we chase are leading us, and love is all we'll ever trust. Yeah, no, I don't wanna waste what's left. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways. And on we'll go. We'll go, finding life along the way, melodies we haven't played. No, I don't want no rest, echoing around these walls, fighting to create a song. I don't wanna miss a beat. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways. And on we'll go. And we'll grow in number, fueled by them to see the horizon, turn us to thousands. And we'll grow in number, fueled by them to see the horizon, turn us to thousands. And on we'll go, through the wastelands, through the highways. We'll go, through the wastelands, through the highways. And on
Open eye, feel the waves cut through me, hypnotized by the sounds I'm breathing in. Hold tight, chemicals collide. Hold tight, hold tight, hold tight. Dripping lights paint the skies, all because of you. Dripping lights paint the skies, only you can make me move. You can make me move. Can make me move. You can make me move. Can make me. So alive, make it last forever. Stop in time, yeah, I'm surrendering. Hold tight, chemicals. Can make me
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem sort an array. Basically, we're given an integer array of nums and we want to sort it in ascending order using an algorithm of our choice, but there's a restriction in that we can't use any built-in functions. So you can't just call sort on the input array and then return it, though that probably will pass on LeetCode. In this case, we also want to solve the problem pretty efficiently in n log n time. There's a few algorithms that can satisfy this complexity. The most famous ones are merge sort and quicksort. Both of these are recursive algorithms. Well, merge sort runs in n log n time. Quicksort on average will run in n log n time. In the worst case, I think it can be n squared. In the best case, it can be n log n, but usually people will assume that quicksort is an n log n algorithm. Now, there's actually a third approach as well, which is called heap sort, which runs in n log n time usually. Basically, you build the heap given all of the items, and then you keep popping them in descending order, well, ascending order, and popping will take log n time, and doing it n times will be n log n. That's using heap sort. I think you can also do it with a binary search tree, which will be n log n. That's using heap sort. I think you can also do it with a binary search tree, but I think these are enough options for us to choose from. I'm going to go with merge sort, though I encourage you to try out these other approaches. I think merge sort is one of the more difficult ones among this list, but I guess it's up to personal preference. Also, the quicksort approach does not pass on LeetCode, at least for me, the way I wrote it in Python. Focusing now on merge sort is one of the more difficult ones among this list, but I guess it's up to personal preference. Also, the quicksort approach does not pass on LeetCode, at least for me, the way I wrote it in Python. Focusing now on merge sort, the idea is that we're given an array, and we want to take a divide and conquer approach. So we could take this entire array and sort it. There's many algorithms that will work in n squared time. But if we break this problem up into subproblems, like we split the entire array into two equal size halves, and then we sort these independently, this is actually more efficient. This will work in n log n time. Let me show you exactly how. So in this case, we have 4 values, so we're going to split them into 2 halves of size 2 each. Now, if we had like an odd number, if we had 5, well, it doesn't really matter too much in that case. We'll put 2 on one side and then 3 on the other side. But we're going to keep doing this recursively, just like this. And then recursively for these, we're going to break them down into 2 halves as well. So put the 5 over here and the 2 over here. And we keep doing this until we can't do it anymore, which now we basically can't, because now we have individual values. We can't really split these up anymore. This is going to be our base case. Now with merge sort, the easy thing is getting to the base case. Afterwards, though, we do the second step. This is called the divide step. It's pretty simple. We just take an array and keep splitting it into halves until we can't do so anymore. But now the second step is the actual conquer phase, where we're actually going to be performing the merge of merge sort, which is when you have 2 individual elements, it's pretty dang simple to merge these in sorted order. We just compare to find which one is smaller. If they were equal, well, then it wouldn't matter. But in this case, 2 is smaller than 5. 5 is greater. So how are we going to merge these two? And when I say merge, I mean we're going to be at this step where we recursively divided this into half. We returned a 5 up here, and we returned a 2 up here. Now we want to merge these. We take the smaller one, 2, and we basically swap these 2 values. So now this subarray, which was originally stored over here, by the way, is now going to look like this, 2, 5. And same exact thing on this right side. We return the 3, we return the 1. Now, which one of these 2 is smaller? The 1 is smaller, so it should go first. So 1, 3. When we say this, these values are actually going to be stored here in place because we only have one single array. We're not creating copies of it when we go and split these up. But now when we take these and we return up to our parent, we're not actually returning these values. Like I said, we're going to be merging in place in this thing. Now that we're going to be merging 2 arrays that are greater than of size 1, it's becoming obvious that to merge them in place in this memory, we are actually going to have to allocate extra arrays. So when we do the merge step and we return up to our parent here and here, we're going to create temporary arrays of this and this. This will make more sense, by the way, when we actually code it up. It's not as complicated as it may seem. But now, to actually merge these 2, it's going to be a bit more interesting because it's not just one value each. We're going to use a 2 pointer technique. So we're going to have one pointer at the beginning of this array and one pointer at the beginning of this array and a third pointer actually at the beginning of this array. So here
what I have done here, यहाँ पे quick shot है, quick shot कॉल हो रहा, इससे पहले partition कॉल हो रहा जो nums array ले रहा, low ले रहा, high ले रहा, pivot ले रहा. अगर high बड़ा है low तो वही low.
here is where we're going to decide which value to put. And of course, we want to put the smaller value. So compare 2 and 1, 1 is smaller. So we put a 1 over here. Then we move our pointer over here. And since we've used the 1 over here, we also shift this pointer to now be over here. Now, which one of these two is smaller, 2 or 3? Well, it's going to be the 2. So we put the 2 over here and take this pointer and then shift it by 1 over here and take this pointer and shift it by 1 over here. Now, again, just repeat which one of these two is smaller. 3 is smaller, so we put the 3 over here, and this pointer is going to be now shifted over here. It's out of bounds at this point, so we would basically just fill the rest of the array with values from over here. So we're basically just going to now put the 5 over here, and that's our entire array after we have sorted it. So it's that simple. Now we're going to get into the code, but quickly, why is the time complexity of this n log n? Well, there's two phases here. One is actually dividing the array into sub-problems. How many times can you take an array of size n and divide it by 2 until we get to the base case where we have arrays of size 1? How many times can we do that? In other words, how many levels are going to be in our tree? Well, by definition, what we are asking is 2 raised to some power, let's call it x, is going to be equal to n. Well, what we are asking is n divided by 2 times 2 times 2 times 2, however many times we're dividing this by 2, which is, in other words, 2 to some power called x. How many times can we do this until this is equal to 1, until n has been divided so many times that it's equal to 1? Well, you rearrange this math equation and basically take the log of both sides, and what you will get is log n is equal to x. That basically means that the height of this tree is going to be log n. Okay, well, what's the time complexity of each level of the tree? In other words, what's the time complexity of performing a merge for an entire level? Well, look at every single level. How many values are in this level? 5, because we have each individual value. Well, 4 values. I counted that wrong. Sorry about that. And how many values are in this level? 4. How many values are in this level? 4. There's going to be n values at every single level that we're going to merge. So the overall time complexity of a single level is going to be big O of n. How many levels do we have? We have log n of them. So you multiply those two together and the time complexity becomes n log n. So now let's code it up. So we know that with merge sort, it is a recursive algorithm. So I'm going to define a function called merge sort, which is going to take in some array, and I'm going to use a couple indices left and right to determine what portion of the subarray are we now running merge sort on, because we know we're going to keep dividing this. So to do it in place, we can use pointers. We could have alternatively created copies of this array or created subarray copies, but this will save memory. So the main base case with merge sort is, what if the size of the array is 1? That would happen if the left pointer became equal to the right pointer. In that case, we would just return, and I'm just going to return the array. Otherwise, we actually have to do some recursion, which is we want to run merge sort on the left and right half of the array. How do we do that? Because we have to supply the array, and we have to supply the left and right boundaries of what defines this subarray. So if we want the left half of this array, we would take the left index and say that's the left boundary, but we'd also need the middle boundary, which is somewhere in between left and right, probably halfway in between, which we can get just like this. Mid is equal to left plus right divided by 2. This is integer division in Python because an index is going to be an integer. And then we also want to call merge sort on the right half of the array. So for the left boundary, we're going to say m plus 1 because the left half was from left up until mid. So the right half is going to be mid plus 1. up until the right boundary. So after we run merge sort on the left and right half, it's going to get to the complicated part, which is merging. But I'm going to use a helper function for that just to abstract a bit of stuff for us right now. We're going to pass in the array into our merge function. We're going to be merging these two halves. So to pass in the necessary information here, let's also pass in the left pointer. And for convenience, we'll pass in the mid pointer as well, even though given the left and right pointer, this function could compute the mid pointer, but this is just a bit easier in my opinion because we already have it here, so might as well just pass it in. And after that's done, we know the array will be sorted, so we would return the array. Now, to actually run merge sort, we would call it on the input array, which is called nums, and we would pass in the left and right boundaries. Left is going to be 0, the right boundary is going to be the length of the array minus 1, and this itself will return the array, so let's just return this, and that's pretty much the solution, but we forgot about this merge function. But this is
समझ नहीं आ रहा.
हेलो एवरीवन, वेलकम टू माय चैनल कोड स्टोरी विद माइक। तो आज हम अपने सॉर्टिंग के प्लेलिस्ट का क्वेश्चन नंबर 3 करेंगे। मीडियम लेवल का क्वेश्चन है। क्वेश्चन तो बड़ा सिंपल है, आपको अरे को सॉर्ट करना है, दैट्स इट। बट कभी भी अंडर एस्टिमेट मत करना, ये क्वेश्चन काफ़ी इंपॉर्टेंट है। 2 लिख दिया, यही मेरे और जो मेरे मैप में प्रेजेंट होगा और जितनी
and 1 and in the so this else block will be executed for every unique element.
एलिमेंट्स होगा लाइक 2 एंड 5 की तरफ, मतलब इन दोनों को हम कंपेयर करेंगे कौन सा एलिमेंट छोटा है कौन सा एलिमेंट बड़ा है।
Yo, what's up, guys? Welcome back to 你是7分，好，接下来我们就写一下。
तो बनाएगा ना भी अंडा लाया है बना ले तो टाइम तो Risky stuff, mate. साला अरे सॉर्ट इतना टफ कैसे हो सकता है? वहाँ पे उन्होंने जो टाइम कॉम्प्लेक्सिटी डिफाइन कर दिया ना, वही दिमाग का दही कर दे रहा। ठीक है, देखते हैं, कर ही लेंगे। फिर से देखेंगे, फिर से देखेंगे, देखते रहेंगे, देखते रहेंगे। एक ना एक टाइम तो समझ आ ही जाएगा। यहाँ पे क्या किया हुआ है इन्होंने? शॉर्ट एरे मर्ज शॉर्ट, ठीक है, मर्ज शॉर्ट को डिफाइन किया है। मर्ज शॉर्ट, ये खुद मर्ज शॉर्ट को कॉल कर रहा है एलिमेंट के लिए। चलो कंपेयर करते हैं इसके सॉल्यूशन को। मर्ज टू view appearance, edit layout, two columns. Java, mid Java, root Java. कौन भड़वा चाइनीज लिखने लगा? Can't even translate it. कुत्ता करता है बहन का लोड़ा. हाँ फिर से देखते हैं.
This is so modularized that. Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem sort an array. Basically, we're given an integer array of nums and we want to sort it in ascending order using an algorithm of our choice, but there's a restriction in that we can't use any built-in functions. So you can't just call sort on the input array and then return it, though that probably will pass on LeetCode. In this case, we also want to solve the problem pretty efficiently in n log n time. There's a few algorithms that can satisfy this complexity. The most famous ones are merge sort.
तो मोबाइल से कनेक्टेड है.
You are live.
अरे अच्छा समझ गया मैं कैसे करें.
लाइव स्ट्रीम कर रहा हूँ.
मैं समझ गया.
कोशिश कर रहा, भेजा तो फ्राई हो रहा, बट देखो you are live.
हाँ हाँ मैं समझ गया.
कोशिश कर रहा हूँ.
ऐसी लाइव स्ट्रीमिंग में पढ़ाओ तो.
पढ़ अभी खुद मेरे को पढ़ने की जरूरत है. मैं पढ़ थोड़ा खुला रख. मादर चूत बहुत हल्ला कर रहा है वो. थोड़ा खुला रहने दीजिए, हवा आ रहा.
गिर गया भाई. वहाँ तो 17 करोड़ लोग देख रहे हैं.
Now, we have seen what is merging, and also we have seen how multiple lists can merge together, that is in two-way merging or n-way merging we have seen. And if there are multiple lists, then we can merge them in different patterns. We have seen that. Now let us see merge sort, that is a recursive procedure. And this is divide and conquer procedure. The divide and conquer strategy says that if a problem is large, then break the problem into sub-problems, and if the problem becomes small, then solve it. And combine the solutions of the small problems or sub-problems to get the solution for main problem. So here the problem is to sort these elements, and we say that the list is very large. Then what is small? So basically if there is a single element, then we say it's small. So single element means we don't have to sort it. So yes, in merge sort we say if there is just a single element, then we don't have to sort it. Otherwise, if there are two elements also, we have to call it as a bigger problem or large problem. If there is a single element, then we say it's a small problem. Merge sort follows divide and conquer, therefore it's a recursive algorithm. Let me write the algorithm. Then I will trace the algorithm. Let us see. Algorithm merge sort. What are the parameters it takes? It takes two parameters, that is beginning of a list and ending of a list. So low and high. Then we check if low is less than high, means if low is equal to high, it means there is a single element. Low is less than high means at least there are two elements, so list is large. If low is less than high, then we will find out mid, that is low plus high by 2, What for we are finding mid? Like if I find 1 plus 8 by 2, that is 9 by 2, I get 4. So this will be mid. What for? We say that this problem is large. What are the parameters it takes? It takes two parameters, that is beginning of a list and ending of a list. So low and high. Then we check if low is less than high. Means if low is equal to high, it means there is a single element. Low is less than high means at least there are two elements. So list is large. If low is less than high, then we will find out mid, that is low plus high by 2. What for we are finding mid? Like if I find 1 plus 8 by 2, that is 9 by 2, I get 4. So this will be mid. What for? We say that this problem is large, so we break it into two sub-problems. That's what we find mid. Then what to do with the left-hand side? Perform a sort recursively. Perform a sort on the right-hand side recursively. So perform mid, find out mid, and perform merge sort from low to mid. And also perform merge sort
from mid plus
from
1 to
mid plus 1 to high. So by performing merge sort on the left hand side, we will sort this one and we sort the right hand side. So when two lists are sorted, we are breaking this into two lists, and when two are sorted, we can merge them together. So perform merge. Merge from where? Low to mid is one list and mid plus 1 to high. So we pass three parameters. So that's all. This is a simple algorithm for merge sort. This is divide and conquer. How
Bro, how did you make it so easy? Wait, let me write. Let it me write. How did you, or how could you? How did you or how could you? What's so different there? How did you? Here we are angry. We are expressing our we are making our face red and asking how did you and how could you? Here we are sounding what how we can say we can how could you means in this sense तुमने मेरे साथ ऐसा कैसे किया in a low voice मैं सुना अंग्रेज नहीं मुझे बस पता है बाकी बाकी पता नहीं पाँव में अलग पेन हो रहा है भाई पाँव की बैंड बची हुई है चलो फिर से करते हैं फिर से शुरुआत करते हैं हम बारी जी आप चालू हो जाइए हम देख रहे थे मर्ज शॉट merge short it follows divide and conquer approach पहला याद करने का सबसे आसान तरीका है लिखना और मैं इसी से हमेशा भागता हूँ मुझे लिखने की इच्छा ही नहीं होती सब ठीक है इधर नाइस, ठीक है। बारी जी, कहाँ हो आप, आइए। इट अप्लाइज डिवाइड एंड कॉन्क्यर approach. It means we are dividing problem into two sub problems. तो क्या बोलता है मर्ज शॉर्ट में, मेरे पास अगर यहाँ पे एक एरे है, एरे इज अ collection of same type of elements और एरे की साइज हमें पहले ही डिफाइन करनी पड़ती है, ये डायनेमिक नहीं होता है। यहाँ पे 9 8 7 3 5 4 10 12 ये मेरी एक एरे है। 0 1 2 3 4 5 6 7 जिसकी लेंथ 8 है। ये मेरा लो है, ये मेरा हाई है। तो एरे कहता है एल्गोरिथम मर्ज सॉर्ट कहता है, इसमें आर्गुमेंट्स मिल जाएंगे फर्स्ट इंडेक्स की, like index of the first element of the array and index of the last element of the array। और ये कहता है कि अगर if l जो है वो h से छोटा है, इसका क्या मतलब हुआ, इसका मतलब जो l है वो h से छोटा है, तो मतलब इसका मतलब बहुत सारे एलिमेंट्स हैं, ये सिंगल एलिमेंट नहीं है। अगर l h से छोटा नहीं होगा तो मतलब वो सेम को ही बता रहा होगा, तो एरे में एक ही एलिमेंट है, तो शॉर्ट करने की जरूरत नहीं है। तो इसके लिए सबसे पहले हम मिड निकालेंगे। मिड हो जाएगा l प्लस h डिवाइडेड बाई 2 और फिर हम मर्ज शॉर्ट कॉल करेंगे। मर्ज शॉर्ट कॉल करेंगे, इसमें आर्गुमेंट्स क्या जाएगा, इसमें आर्गुमेंट्स जाएगा मेरा l जाएगा और मिड जाएगा। ये तो मेरे मिड के पहले का एलिमेंट को शॉर्ट, मिड के पहले के सारे एलिमेंट्स को हम शॉर्ट कर रहे हैं। और फिर तो क्या मिड के बाद का क्या होगा, तो उसके लिए अलग मर्ज शॉर्ट करेंगे जहाँ पे मिड प्लस 1 और वो जाएगा लास्ट इंडेक्स ऑफ द एरे तक, ये रहा h। अब ये क्या, मर्ज से पहले का शॉर्ट हो गया, मतलब मिड से पहले का शॉर्ट हो गया, मिड से बाद का शॉर्ट हो गया। अब हमें इन दोनों को भी मर्ज करना होगा, तो उसके लिए हम मर्ज कॉल करेंगे। जो लेगा l लेगा, लाइक स्टार्टिंग इंडेक्स, मिड लेगा और h लेगा। चलिए गुरुजी
Merging
आगे
is
बताइए।
done. We have already seen the procedure how merging is done. But the point here is, when the single array is given for sorting, we are breaking into two sub-arrays and we are saying this is one first list and that is second list. So single array will be containing two lists and we have to merge them. So can a single array have more than one list? Yes, a single array can have many number of lists. Let us see how it works.
सिंगल
Let us see
एरे
the
का है
trace.
मल्टीपल नंबर ऑफ लिस्ट। इसमें बाबा क्या बोलना चाहते हैं, कभी कभी बातें, इनकी बातें सारे पढ़े लगते हैं मुझे।
Now based on this algorithm only I will do tracing. Initially we'll be passing low as 1 and high as 8. So let us take for these set of elements. So first time we will pass 1 and 8. It will find out mid and it will divide the list and this side and that side. So mid is perform and perform a sort from low to mid, that is from 1 to 4. It will go this side. And it has to go on the right hand side also, but not now, it will go afterwards. But I will draw this one also. So let us take this one. So it will call itself from 5 to 8 on the right hand side. So it has broken them into two lists, first part and the second part. And then afterwards merge. So first of all, let us finish this and this. Now merge sort calls itself. Low is less than high. Yes, 1 is less than 4. So again find out mid and call these 2. So it means these 4 elements are also large. Divide them. So this side 1 to 2 and this side 3 to 4. Now when we take this, again low is less than high. Yes, there are 2 elements, so this is still large. Again split it. So 1 to 1 on this side and 2 to 2 on this side. Now there are just 1 elements. See, if you have seen previous video, you may know how two-way merge works, two-way merge sort works. See, if you have seen previous video, you know how two-way merge sort works. Now here also merge sort is working in a similar way. One array was given, so it has splitted and then splitted, then splitted. Now it has reached one element. Now one element is there means it's a single list with one element. Now these two can be merged together. 3 and 9 are merged together. So the first merging is done for these two elements and their result is obtained here. So this is the first merge done. This is the first merge done. It will merge these two elements. So 3 and 9 are merged. Then coming to this side, it will split them and get 3, 3 on this side and 4, 4 on this side. Then it will merge the elements. 3 and 4 are merged. So first 9 and 3 were merged. So the result was 3, 9, and now 5 and 7 and 5 are merged. Result is 5 and 7. This is combined. Now it will go back and perform merge here. So this is the third merge. So it will merge these two. So the result is 3, 5, 7, 9.
अच्छा, जब बाबा ने बोला कि एक में मल्टीपल लिस्ट हो सकता है, तो इसका ये मतलब था कि लाइक ये जो नीचे डाउन टू टॉप मर्जिंग चल रही है, तो डाउन वाले पहले मर्ज हो रहे हैं, उसके बाद वो नई नई लिस्ट बन रही है, जो दो नई लिस्ट बनी फिर उसमें वो एलिमेंट्स को मर्ज कर रहे हैं.
This side is sorted. Actually we have to sort this whole array. Break it and break it and break it. Now two elements merge, two elements merge. Now merge these two also. So this side is sorted. Now same thing is done on the right hand side also. 5 to 8 is there. So on that side it will divide this from 5 to 6. And that side it will be 7 to 8. And 5 to 6 will become 5, 5 and 6, 6. Now one element each. This is again splitted, one element. So these two are merged. So it becomes 4, 6. So this is the fourth merging. Then it will go this side. It will split again, 7, 7 this side and 8, 8 this side. So it will split this also. Then again these two are merged. So it becomes 2, 8, one more list. So this is fifth merging. Now as these two are already sorted, it will merge these two. So it becomes 2, 4, 6, 8. So this is sixth merging. And then these two lists are merged to get a single list, that is 2, 3, 4, 5, 6, 7, 8, 9. This is single sorted list, that is seventh merge here. So this is how merge sort works. When a single array is given, recursively it will divide that array into smaller pieces until it reaches one element. Then it will start merging them. So you can see that 8 elements were given, splitted, then splitted, then splitted. Now they are merged, merge, merge. So this is the working of merge sort.
ओके, जैसा आप कहें गुरुजी. चलिए, बाय डिस्कट क्या होगा? 0 plus 7 divided by 2, 7 divided by 2, 7 divided by 2, ये हो जाएगा में डाल दिया 3, 2, टूटेगा 0 2 1 में, 2 1 में, और फिर 2 2 3 में। फिर ये टूटेगा 0 में, 1 में, फिर ये टूटेगा 2 में, और ये 3 में। ये टूटेगा 4 और 5 में, ये टूटेगा 5 और 6 में, टूटेगा 4 में, ये टूटेगा 5 में, 4 5, ये टूटेगा 6 में, ये टूटेगा 7 में। तो ये पहला होगा, फिर दूसरा ये होगा, फिर तीसरा ये चलेगा, चौथा ये, पांचवा ये, छठा ये, दोनों मिल के चलेंगे 0 से लेकर 7 में। सातवां ये चलेगा। तो जब मर्ज शॉट कॉल होगी, जब मर्ज शॉट कॉल होगी, जब मर्ज शॉट कॉल होगी, ये इसको पॉइंट करेगा। फोकस टूट गया बीच में। Baba,
All right.
Gyan.
So it's similar to two-way, but in two-way merge sort, we just take first two element, the next two, the next two. But this is divide and conquer, and this is recursive. So it will simply divide, and then that's how it reaches one element. Then it will start merging them. So what is different is only the pattern is changing. The approach, rest of the things are same. Right? Result is sorted, and it is also merging two lists at a time. So it is also two-way. But as it is recursive, we need some another name, so we call it as merge sort. Let us see the time taken by merge sort. So from the tree, the recursion tree, that is the tracing of that algorithm I have done. So I'll show you how the time is, I will show you how much time it takes. See, the merging has started in this level. This was just splitting. So how many elements are merged here? Two elements merged, two elements. Total how many elements? 8 elements are there. 2, 4, 6, 8. 8 elements are merged here. So I will say n element. Elements are merged, all n elements. Then again merging is done at this level. So 8 elements are merged. Then again 8 elements are merged here. So n elements are merged each time. So total how many levels are there? 1, 2, 3 or 1, 2, 3. So total 3 levels are there. So for 8 elements, I got 3 levels. It means it is log of 8, log of 8. 1 and then 2, then 4. So when something is raising by 2 every time, and it is power of 2 lastly, power of 2, that is 3, at the last we are having 8 elements total. So 3 is log of 8. So how many passes are there? So actually these are not passes because it is recursive. First it will enter this side, then it will go that side. So it is not passes, right? First it will finish left side, then right side. But levels if you see. So total how many levels? Log n levels are there. So this will be n, how many times? Log n times. So the time taken by merge sort is theta of n log n. That's it. So the time for this one is also n log n. Now taking these numbers, I'll show you how this merge sort works. Low and high are taken. So example is 1 and 8. 1 and 8. So let us see, using the numbers I'll show you. First of all, it will find out mid and it will call merge sort on the left hand side. So it will take these numbers and call 9, 3. Now taking these numbers, I'll show you how this merge sort works. Low and high are taken. So example is 1 and 8. 1 and 8. So let us see, using the numbers I'll show you. First of all, it will find out mid and it will call merge sort on the left hand side. So it will take these numbers and call 9, 3, 7, 5. Merge sort is called on this. Then now this is 1 to 4. 1 to 4. Again, this becomes 1 to 4. So this is the first call, right? First call. Then 1 to 4, the first recursive call. 1 to 4 is 1 is less than 4. So again it will call itself by finding mid, it will call itself. So again it will split. So this is 9 and 3. So just 1 and 2. 1 and 2. Then again this is also low is less than high. This is low and this is high. Just you can follow that one. Find out mid and split it. So 9 on this side. This is just 1 comma 1. And 3 on this side, just it is 2 comma 2, right? So it has called itself and itself and itself again. So this is one list, it has splitted, then again this is splitted, again this is splitted, and this side. Now these two are merged, so the result become what? 3, 9, right? Then it will go on the right hand side, so this becomes 7, 5, that is 3, 4. Then it will come on the left hand side, this is just 7, 3, then it is just 5. So these two are merged, so it becomes 5 and 7. Second call has finished. Now this side is completed, this side is completed. So what is the next step? Merge. So these two are merged, so this becomes what? First 3, then 5, then 7, then 9. So that's how it has splitted, then splitted, then splitted, then merged. So till here it got the result. Now it will go on to the right hand side. So this part, second part for this one. So this will be 6, 4, 8, 2, and this is from 5 to 8. 3, 7, 5. Merge sort is called on this. Then now this is 1 to 4. 1 to 4. Again, this becomes 1 to 4. So this is the first call, right? First call. Then 1 to 4, the first recursive call. 1 to 4 is 1 is less than 4. So again it will call itself by finding mid, it will call itself. So again it will split. So this is 9 and 3. So just 1 and 2. 1 and 2. Then again this is also low is less than high. This is low and this is high. Just you can follow that one. Find out mid and split it. So 9 on this side. This is just 1 comma 1. And 3 on this side. This is 2 comma 2. Right? So it has called itself and itself and itself again. So this is one list, it has splitted, then again this is splitted, again this is splitted, and this side. Now these two are merged, so the result become what? 3, 9. Right? Then it will go on the right hand side, so this becomes 7, 5. That is 3, 4. Then it will come on the left hand side, this is just 7, 3. Then it is just 5. So these two are merged, so it becomes 5 and 7. Second call has finished. Now this side is completed, this side is completed. So what is the next step? Merge. So these two are merged. So this becomes what? First 3, then 5, then 7, then 9. So that's how it has splitted, then splitted, then splitted, then merged. So till here it got the result. Now it will go on to the right hand side. So this part, second part for this one. So this will be 6, 4, 8, 2, and this is from 5 to 8. This one. Now on this, 5 to 8. On this one it is called 5 is less than 8. Yes. Again find out mid and call merge sort. This one. So on the left hand side it will be called. So this will become 6, 4. It will be 5, 6. Indices are 5, 6. Then on this again merge sort is called. So 5 is less than 6. So again find mid and call merge sort. So it will become 6 and this is index 5. Now low is also 6, high is also 6. It will go on the right hand side, this call for this one. So this will be 4 and the index is 6. So low is also 6, high is also 6. Then merge, these two are merged. So it becomes 4 first, then it becomes 4 first, then 6. Then it will go on the right hand side of this one. So right hand side is 8 and 2. This is index 7 and 8. Now low is 7, high is 8. So low is less. Again find out mid and call this one. So this side it will be 8 and it will be 7. Now just one element. So go the right side. 2, single element. Now merge. So left side completed, right side completed. Now merge. So 2, 8. It becomes 2, 8. Now this side, both are sorted, merge. Both are sorted, then merge. So this becomes 2, 4, 6, 8. So this becomes 2, 4, 6, 8. Now this is also sorted. This was already sorted beforehand, left hand side it went. Now these two are merged together. 2, 3, 4, 5, 6, 7, 8, 9. So in this way, this list becomes 2, 3, 4, 5, 6, 7, 8, 9. Sorted. This is how merge sort works. Tracing I have done. See, earlier I have shown just indices. Now in this I am showing numbers. And as it is calling itself 2 times, the tracing tree will be more like a binary tree. It will be like a binary tree. And if I say the traversal, then in which traversal merging is done? Post order. First left, 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 then right, then root, merge. Right? Then right, left, then right, then root, merge, root, merge. So merging is done in post order traversal. That's it. So I have shown you tracing in 2 different ways. Now let us find out the time complexity of this algorithm by using recurrentialization. For this recursive algorithm, let us prepare recurrentialization and find out the time complexity of merge sort. If I say this algorithm takes Tn time, then this is one condition, and this, if I ignore condition and I say this is calculating mid, then it is calling itself, so T of what? Half of the list, low to mid, half of the list, so n by 2, and again calling itself, so this is also n by 2. Then it is merging from where? Low to high. 2 lists are there, low to mid, mid plus 1 to high, 2 lists, total n elements. So merging takes n. So if I prepare recurrentialization by adding all these, ignore one there. Now this is Tn is equals to 2 times Tn by 2 plus n. So the recurrentialization is Tn is equals to 2Tn by 2 plus n when n is greater than 1. What it is doing when n is equals to 1? It's not doing anything. So we don't write 0, we can write 1 or some constant. Okay, some constant means 1, 10, anything you write. It's not doing anything, so better write 1. That's the recurrentialization. Now by using Master's theorem, a value is how much? 2, b value is how much? 2, and f of n is what? N. Now find out log a base b. So that is log 2 base 2 is 1. And power of n, k, it is 1. So this is log 2 base 2 is equal to k. They are equal. So we compare these two, and this is falling in case 2. Case 2. So case 2 says what? Whatever f of n is multiplied by log n. Write f of n as it is and multiplied by log n. So I am using Master's theorem. Already this recurrentialization is solved in another video. You can look for that video. right? It is in the second topic, that is divide and conquer. I have solved few recurrence relation. This you will find in the title of a video itself. Now here directly I am using Master theorem. There are videos on Master theorems also. So time is theta of n log n. Hi, let us look at pros and cons of merge. External merge sort uses the same method. So merge sort times that's it. That's the stability. If already you have some large, if it is large, we break it into small sub problems. Hello friends, I'm going to start a course. Hi, the topic is merge sort. So for understanding merge sort, first of all, we elements 2, 4, 8, 3. Copy this for wherever I may be. Don't initialize it. Let it be at the same place. Wherever it is. And I is less than equal to m, I plus plus. And in C of k plus plus, copy A of I. 5 plus plus is already there, so just I'm saying copy the remaining elements from list A to list C. Otherwise, if there are, this list is having m number of elements, and this linked list also. So irrespective of data structure, just we are looking at two lists. Now let's understand how to combine them. So for each list, I need some index pointer. Let us take I here, and j here, and k for this C list, which is in the beginning of empty list. Now, procedure starts. The procedure for merging is like this. Compare A of I with B of j. If A of I is smaller, then copy that one here. And the element which is copied there, you move index, and this index also moves to next location. Now next, compare A of I with B of j. This is smaller than this one, so copy this element and move to next element here. And here also move to next free location. Continue. A of I with B of j, 8 is smaller, copy this one. Then move to next. And move K of Hi, the topic is merge sort. So for understanding merge sort, first of all, we should know what is merging. So let us know about merge. That is merging. See, merging is a process of combining two sorted lists into a single sorted list. So if I have two lists, let us say A is one list.
मैं हूं बैरागी भोले तेरी वजह से हूं मैं प्रेमी हूं मैं पापी हूं मैं माल पी के मजे में हूं मैं नशे में हूं इतना ज्यादा कि बुरे कर्म भी ठीक लगे मैंने दौलत मैंने जो भी कमाया वो सब मुझको ठीक लगे कभी मेरी थोड़ी दया मालिक हूं मैं सुबह मैं मेरे पानी का आदी हूं कुछ मेरे बर्बादी हूं कभी बेचारे शैतानों से महादेव मैं हूं बैरागी भोले तेरी वजह से हूं मैं प्रेमी हूं मैं पापी हूं मैं माल पी के मजे में हूं मैं नशे में हूं इतना ज्यादा कि बुरे कर्म भी ठीक लगे धन दौलत मैंने जो भी कमाया वो सब मुझको भीख लगे कभी दिल मेरी तो कभी दयावान कभी हूं रात कभी भया फहम मैं मंदिर पान का आदि हूं खुद से खुद में बर्बादी हूं मेरे कभी विचार शैतानों से और कभी विचार है साधु के कभी कभी मन शांत ये रहता कभी कभी बेकाबू है श्रद्धा और सद्भाव रहे तो हो जाता हूं पावन मैं पर भोग विलास और मंदिर पान से बन जाता हूं रावण मैं मांस पके जब करेगा हम राक्षस बनकर खाएं उसे पर बेकसूर इस पशु की हत्या कभी कभी न भाए उसे एक शरीर है दो मनुष्य लगता मेरे भीतर रहते हैं विनाश काले विपरीत बुद्धि सब कुंडली देख के कहते हैं एक तो है सीधा बड़ा और दूसरा बहुत ही पापी है मेरी हरकतों से बस पता चले कब कौन सा मुझ पर हावी है मैं जानू ना कुछ भी अब तो ये कलेश जो मुझ पर आया है ये उपज है मेरे दिमाग की या किसी भूत प्रेत का साया है कोई ऊर्जा है नकारात्मक सी महसूस कभी मैं आसपास में समझ में जीवन ना आए तो देखता हूँ मैं आसमान में गार को अपने शुद्ध करूं बदलाव भी होते कर्मों से अब दुनियादारी से नाता तोड़ के आया भोले शरणों में अस्तित्व मनुष्य का छोटा कितना सोच कि मैं ये कांप दिया फिर आंखें मूंद कर ध्यान किया ब्रह्मांड को मैंने नाप दिया दिमाग में ज्ञान संसार का ना पर बुद्धि को एकांत करा मैं पढ़ता गया मैंने बुद्धि में ब्रह्मांड भरा मैं शून्य बना मैं शांत बना डी वॉइस मैं देवांश बना मैं लिखता गया अब कोई लगाम विचार पे ना विचार कोई नकारात्मक सा अब बढ़ता ना मन पर भारी अब बात करे सन्नाटे मुझसे मेरी ही बनकर वाली मैं पृथ्वी हूँ मैं अंबर हूँ मैं पंचतत्व का हूँ ज्ञानी मैं अग्नि हूँ मैं वायु हूँ मैं सब जानू अंतर्यामी खुली हुई मैं किताब सा हूँ मनगढ़ंत कहानी बनाता नहीं मैं प्रलय हूँ मैं अभिशाप सा हूँ अगर बरस पड़ूं तो ठिकाना नहीं मैं नदियों के सैलाब सा हूँ उफान करूँ तो किनारा नहीं मैं पढ़ तो लेता दिमाग भी हूँ कभी आंखों से आंख मिलाना नहीं दिमाग में ज्ञान संसार का ना पर बुद्धि को एकांत करा मैं पढ़ता गया मैंने बुद्धि में ब्रह्मांड भरा मैं शून्य बना मैं शांत बना डी वॉइस मैं देवांश बना मैं लिखता गया अब कोई लगाम विचार पे ना बावफा ना सही खैर है, बेवफा तुम बड़े खूब थे, मैंने पलकों के आंचल में तुझको रखा, तेरे लब पे रही बस यही सदा, तू रहा कर देना, तू रहा कर देना, तू रहा कर देना, हमसे क्या हो सका इश्क में, तुमने फिर बेवफाई की है। दिल में रहे वसवसे कितने, लोगों ने ताने कसे कितने, तुम हाल को अपने समझ न सके, तुम रोए तुम्हें याद तुम हंसे कितने, दिल के मोहल्ले मुसाफिर तो आते गुजरते हैं सब पर बसे कितने, लिखने को तुम पे जी नहीं करते ये सोच के भरे हैं सफे कितने, ढूंढ ला वो जदीद लम्हे, चाहिए हमें शदीद लम्हे, वक्त कम कुछ मजीद लम्हे, सौदे कर ले खरीद लम्हे, पाक लम्हे पलीत लम्हे, वक्त क्या जाते बीत लम्हे, दूरी भी कर गई है बला हम हार के तुमको जीत लम्हे, इश्क सीखा खुदा से तो फिर इस पे क्यों ये सवाल करना, कमाल करना बेहाल करना, आता तुमको निहाल करना, हिजर में गुजरी भीगी रातें, कब तक यूं ही मलाल करना, कैद करना बहाल करना, थोड़ा तुम ही ख्याल करना, कर देना, तू रहा कर देना, रूह से रूह का राबता, इस जहां में तो मुमकिन कहाँ, सारे किस्से तेरे, तेरी हर दास्तां सुनने को।
Hi, the topic is merge sort. So for understanding merge sort, first of all we should know what is merging. So let us know about merge, that is merging. See merging, now I have two lists and 7. Now I got one more list, then 8. 2 is divided by less than or equal to n. The size of the list
भैया क्या लिखे हैं ज़रा इसको एक बार पढ़े तो। कहना चाह रहे हैं पहले शॉर्ट एरे बना हुआ है, शॉर्ट एरे में हमने मर्ज शॉर्ट कॉल किया, नम्स पहले एरे दिया 0 से स्टार्ट हो रहा है और लेंथ -1, रिकर्सिव मर्ज शॉर्ट ये कॉल हुआ, तो ये यहाँ पे आ जाएगा मर्ज शॉर्ट में। मर्ज शॉर्ट में मान लीजिए स्टार्ट इज लेस देन एंड, चेक कर रहा है इफ चेक इफ द एरे हैज ओनली वन एलिमेंट, मिड निकाला, फिर मर्ज शॉर्ट कॉल हुआ नम्स स्टार्ट से मिड तक, फिर मर्ज शॉर्ट कॉल हुआ नम्स मिड्स +1 से एंड तक, फिर उसके बाद हम मर्जिंग कर रहे हैं, फिर यहाँ पे हम मर्ज शॉर्ट कॉल कर दिया नम प्लस स्टार्ट प्लस मिड, तो हमें आ गया मर्ज सॉर्ट कॉल किया, फिर ये आया, ये तब तक टूटा जब तक एलिमेंट हमारा 1 नहीं बचा। एलिमेंट 1 बचा तो फिर हमारा मर्जिंग के लिए आ गया। मर्जिंग में हमारा जहाँ पे हम नम्स एरे पास कर रहे हैं, स्टार्ट इंडेक्स, मिड इंडेक्स और एंड इंडेक्स। हमने एक टेम्पररी एरे बनाई है, इन माइनस स्टार्ट प्लस 1 एंड मान लेते हैं 4 होगा, स्टार्ट 0 है। क्या रे, ऐसे देखो ना, 0 2 0 2 3 है तो 0 1 2 3 4 हो गया। हम टेम्प एरे को भी सेम उसी लेंथ का बनाएंगे 4, तो टेम्प में हम आ गया एंड मेरा 3 है, 3 माइनस 0, 3 माइनस 0 प्लस 1, बेसिकली 4 4 है, 4 हम डिफाइन कर रहे हैं। आई जो है मेरा वो स्टार्ट इंडेक्स हो गया, जी मिड प्लस 1 है, के हमने इनिशियलाइज किया 0, कि हमने इंडाइसेस छोड़ दिया, टेम्परेरी के लिए स्टार्ट किया। वेयर कंपेरिमेंट लेटर स्टोर दिस वन। आई जो है वो मिड से और इक्वल से छोटा है, इसके लिए मिड ही एंड हो गया ना। basically बंद हो गया। पोस्ट इंक्रीमेंट है ना।
Hi, the topic is merge sort. So for understanding merge sort, first of all, we should know what is merging. So let us know about merge, that is merging. See, merging is a process of combining two sorted lists into a single sorted list. So if I have two lists, let us say A is one list, B is one list with some set of elements, like, now there are two lists given and I have taken equal sizes, they can be of different size also, but they are sorted. Now let us see how we can combine them such that the result is also sorted. So I'll prepare a third list, that is C. These lists can be in array also, or they can be in linked list also. So irrespective of data structure, just we are looking at two lists. Now let's understand how to combine them. So for each list, I need some index pointer. Let us take I here, and J here, and K for this C list, which is in the beginning of empty list. Now, procedure starts. The procedure for merging is like this. Compare A of I with B of J. If A of I is smaller, then copy that one here. And the element which is copied there, you move index, and this index also moves to next location. Now next, compare A of I with B of J. This is smaller than this one, so copy this element and move to next element here. And here also, move to next free location. Continue. A of I with B of J, 8 is smaller, copy this one. Then move to next. And move K also to the next. In the same way, if I continue now, 9 is smaller, 9 is copied, then it will move to the next one. Then 12 and 15, 12 is smaller, 12 is copied. Then it will move to next one here, and 15 and 17, so 15 is smaller. Then it will come to this one, I will move here, and these two are compared, 17 is smaller. And finally, K will be on the next free space, and I is still here, J has crossed the list. Now we can see that one of the list has finished. Now remaining elements are there in one of the list. Here an example, list A is having some remaining elements. So simply copy those remaining elements. So that's it. I got a third list, that is with the sorted elements. So we have combined two lists by comparing the elements from each list, and whichever is smaller we have copied them, and we got a sorted list. This process is merging. The property of this process is that if two lists are already sorted, then the result is sorted. So the important thing is the result is sorted.
Now let us look at the time taken by this process. If I say this list is having m number of elements and this list is having n number of elements, then what is done here? M elements and n elements are copied here, so this list is having m plus n element. So what we did, just we compare the elements and we have written the list here. So the amount of time taken for moving the data from here to there is theta of m plus n. Though the time complexities are written just using variable n. But for merging, we use theta of m plus n. So this resemble becomes a notation for merging. M plus n means, okay, merging is being done there. So this has become like a notation for merge. Now we have understood merging. I will write on the algorithm or procedure for merging. What the procedure I have shown you, same thing, I will write on the code there. Algorithm merge, which takes list A and B and its sizes m and n. Algorithm merge is taking two lists A, B, and let us say m and n. It depends, whatever you like, you can pass the parameters. It depends on you. Now, what we are doing here, we have taken I, that is at beginning place, and j also at beginning place, and k also at beginning place. Initially, if you remember, that means I is 1, j is also 1, and k is also 1. So I'm starting this from 1 onwards, not like C, C++ where we start from 0 onwards. So for making it simple, I'm starting from 1 onwards. Now, what's the procedure? We compare A of I with B of j. So if A of I is less than B of j, then in C of k, I should copy A of I. If this is smaller, copy this one, and move I and k also. So k plus plus and I plus plus. If this is not smaller, this is smaller, else. In C of k plus plus, copy B of j plus plus. This process will continue. That's what we have seen. Compare them and copy whichever is smaller. So this process will continue. How long? As long as I is less than or equal to m and j is less than or equal to n. The size of the list is m and the size of this list is n. This process will continue. And once this process completes, this loop completes, we know that any one of the lists will have some remaining elements. Like in our example, 18 was remaining in the first list. So I should copy the remaining elements. So we don't know in which list the elements will be remaining. Maybe in A or maybe in B. See, if suppose, here I have few more elements, 18, 19, 25. So there are 3 elements. So I is pointing here. From here onwards, I should copy all the elements. Means wherever I is pointing, I should copy all the elements. Or else, here I may be having some elements, 19, 25, 30. So j may be here. So wherever j is, I should copy the rest of the elements. So here I write for wherever I may be, don't initialize it, let it be at the same place, wherever it is. And I is less than or equal to m, I plus plus. And in C of k plus plus, copy A of I. 5 plus plus is already there, so just I'm saying copy the remaining elements from list A to list C. Otherwise, if there are some remaining elements in second list, then copy the remaining elements from second list. This procedure for merging. Here, this procedure, this while loop, is for comparing and copying elements. Then the first for loop is, if there are any remaining elements in list A, copy them to list C. In for loop is, if there are any remaining elements in list B, copy them into list C. This is merging. Now let us see, if there are more than 2 lists, then how merging is done. Let me take 2 more than 2 lists. Now here I have multiple lists, let us see how I can merge them. So I can there are more than 2 lists, then remaining elements in list B, copy them into list C. This is merging. Now let us see, if there are more than 2 lists, then how merging is done. Let me take into list C.
मर्ज कैसे कॉल हो रहा है? मर्ज को कॉल करने के लिए हम क्या कर रहे हैं? मर्ज कॉल कैसे हो रहा है? सबसे पहले तो यहाँ पे 2 लिस्ट ब्रेकिंग है। एरे तो पूरा जा रहा है, फिर नम से एरे पास करेंगे। स्टार्ट जाएगा, मिड जाएगा और एंड जाएगा। फिर उसके आगे क्या होगा? फिर आई इनिशियलाइज स्टार्ट से होगा, जे इनिशियलाइज मिड प्लस 1 से होगा और हमारा एक टेम्प एरे भी चाहिए होगा। के इक्वल टू 0 होगा क्योंकि के हमारा डिनोट करेगा टेम्प एरे के इंडाइसिस को। उसके बाद क्या होगा? एक वाइल लूप चलेगा, I less than equal to mid है and n j is less than or equal to and है, ठीक है। if nums of I is less than nums of j है, if nums of I is less than nums j है तो temp of k प्लस प्लस में जाएगा nums of I प्लस प्लस नहीं तो एल्स में क्या जाएगा? टेम्प ऑफ के प्लस प्लस में नम्स ऑफ जे प्लस प्लस, ठीक है। ये हो गया। अब क्या हो जाएगा? अब हो सकता है कि इस कंपैरिजन के बाद भी कुछ एलिमेंट्स रह जाएं, तो हम चलाएंगे वाइल लूप I less than equal to mid और टाइप ऑफ k प्लस प्लस में nums of j प्लस प्लस, एक और वाइल लूप चलेगा j less than equal to and में तो temp of k प्लस प्लस में nums of j प्लस प्लस और एक for लूप चलेगा, for लूप चलेगा temp के लेंथ तक, जिसमें क्या होगा? कॉपी हो जाएगा nums of I में स्टार्ट 0 कॉपी हो जाएगा nums of start plus p equal to temp of p। तो चलो करते हैं कोडिंग। चलिए महाजन आप गायब हो जाइए, इसको to short num array in and log and time complexity। तो इसको जो सबसे पहले मेरे पास nums array वो क्या करेगा? nums of ये short ये हमारा कॉल करेगा शॉर्ट को जो लेगा नाम से अरे नाम से अरे 0 नाम स्टार लेंथ -1 कॉल होगी और रिटर्न करेगा क्या नाम से merge short function to approach merge short पे आ गया हम एक create method and start होगा and होगा nums ले start ले रहा है और क्या करेगा if क्या अगर if start जो है लेस देन एंड है तो मतलब मल्टीपल एलिमेंट्स हैं वो क्या करेगा मिड कैलकुलेट करेगा जो होगा स्टार्ट प्लस एंड डिवाइडेड बाय 2 मिड कॉल करेगा फिर merge solve for sub problems okay one shot nums आएगा start आएगा और mid आएगा merge shot nums आएगा ये mid +1 आएगा और end आएगा ओके फिर मार्च आएगा जो लेगा नम्स लेगा स्टार्ट हो गया जो जे है जीरो वन टू जीरो वन आइडिया फोर जीरो अच्छा प्लस वन और इसका प्लस if क्या if nums of I is less than nums of कितना होगा ऐसा होगा तो temp k plus plus में is equals to nums of I plus plus जाएगा तो इसमें क्या हो जाएगा temp of k plus plus में is equals to nums of j plus plus जाएगा copy the rest बट के बराबर भी हो जाता है K2 plus nums of star plus K2 and K2 plus correct and it and the comments on these there what are 20. Boom 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 boom. Binary or boy. Let's play a song. Hello.
सुंदरतर बिना पिनाकधर हर गंगाधर गजाचर भरधर गंगाधर गज भरधर चंद्रचूड़ शिवशंकर पार्वती रमणानि नगे नमो नमः चंद्रचूड़ शिवशंकर पार्वती रमणा